Okay, so I know y'all are doing good. Let me just kind of stop right here because I want to show you some things, especially with the square root one. But this one, I just plugged in the same points. What's negative 2 squared? Does anybody know?
4.
Yeah, positive or negative 4? It's positive. Why? Because a negative times a negative is positive. Okay. All right. So that's 4 plus 6. It's 10. negative 1 times negative 1 is positive 1. Plus 6 is 7. 0 squared plus 6 is 6. 1 squared plus 6 is 7. 2 squared, that's 4 plus 6 is 10. So notice it has like a symmetry to it. And when you graph this, what shape did y'all get? Okay, so I heard a V, and I also heard parabola, right? So it would be that parabolic shape. It kind of looks like a V, 2, 3, 4, 5, 6, 7. Kind of looks like a V and a W, or a V and a U in one shape. But you end up getting this. And then you don't even have to look because you know it's symmetric. So you can just kind of use this one right here. And then you draw that shape. And it should look like some curve to it, not just like a line, okay? That would be in a little bit with the absolute values. So that's that. The other one that was a little bit more challenging was D, but I think y'all could have did fine with this one, especially using the same points. Yeah, so you would do negative 2 squared minus 9 times negative 2 minus 12 and so forth. No, okay, I could come back and do that. You don't have to watch me do that. Okay, maybe just one, right? Because that would be 4 plus 18 minus 12. That's 22 minus 12, that's 10. Okay, and then so on, okay? I think y'all were doing that, that's fine. I'll just put it up just to confirm you got the same thing. What I want to jump to is E, okay? Because I gave you some suggestions, right, to plug in some points. These are my go-to points. Can you take the square root of a negative number though? No, there's no number times itself that's going to give you negative 1. Does anybody know what that is though, actually? Okay, good. I, imaginary number. We'll do that later. But square root of a negative number is an imaginary number. You can't do it. So that's why they call it imaginary, I presume. But so how do I deal with, or how can I graph something like this easily? Pick numbers that you know the square roots of. What are numbers that we know the square roots of? 4. Okay, so that would be a good choice. What about numbers? Any other numbers smaller than 4? 1. I know this. We know the square root of 1. What else do we know the square root of? 9. What's smaller than 1? 0. Right. So these are good numbers to pick for any time you have a square root. Right? Because if you put in 2 here, does anybody know the square root of 2 off the top of their head? Me neither. Okay, so pick these points, right? Pick numbers that you know the square root of, and then that'll help you out. So do that for E and F. E and F. Okay, so go ahead and do those. In other words, pick better numbers than what we first picked for A through D, because it involves a square root, all right? let's go from here. So this one, we have a few points. You might have got a negative 210, right? And then negative 1, negative 2 here, 0, negative 12. And then you'll notice the numbers start getting kind of big. So by hand, I wouldn't probably go beyond that because the graph kind of goes up to here. So this type of question you might be asked like, and you'll see it on MyMathLab, it'll give you like 4 choices. And so basically what you have to do is have to match up your points with the graph, with the correct A, B, C, or D graph. So 1, 2, 3, 4 points would probably be enough points to kind of match it up with what you need. Now it's not to say that I won't have you, so just so you know, here let's think in advance a little bit on the test. Most of the time the way I like to have my test is I actually have it very computer based, kind of like what you'll see on your homework, but we'll be in a lab, okay? We'll be in a computer lab. So, but at the same time, I still kind of want to see some of this other stuff. So I kind of give you maybe 4 or 5 questions on the side, free response. That's the style of the test that you'll see with me. So you still have to kind of know this stuff, all the written part, but a good chunk of it will be what you see on your online homework, which is what you see here, basically just online. But I still like the writing and the graphing. I want to see that part. But so something I would have you write out, I probably wouldn't do a graph like that equation, the equation that was there, because the graph is it's big. Yeah, I don't want you to spend all your time doing that. Okay, we could just take a little bit longer. All right, so that one we'll say it's done. Square root of 0, 0, square root of 1, square root of 4, square root of 9, 3. Okay, so then your graph would start at 0, 0, 1, 1, 4, 2, and 9, 5, 6, 7, 8, 9, 3. Okay, and then the square root function looks kind of something like that. Okay, so far what have we done? We've done parabolic functions, linear functions. Now we've done a square root function. So, and in fact, that's the parent function. That's where all the other square root functions come from, is this one. And then the very next one, you have square root of x plus 5, which, again, even with that one, and sometimes I write the equation up here too. Even with that one, you can still use the very same points. Why? Because you know the square roots of these things, okay? Square root of 0 plus 5, square root of 1 plus 5, square root of 4 plus 5, square root of 9 plus 5. What's the first one? 5. This one? 6. This one? 7. Because square root of 4 is 2 plus 5 is 7. Now it's 8. Okay. So again, you graph these, you're going to get 0, 1, 2, 3, 4, 5, 1, 6, 2, 7, 9, I'm sorry, not 2, 7, 4, 7, 4, 7, and then 9, 2, 3, 4, 5, 6, 9, 8. Okay, how does this one compare to that very first one right here? Yeah, and shifted up 5. How could we have known that without ever even graphing it? The plus 5. That picks up the graph 5 units. Okay, so these are things we'll kind of study down the line, but I think some of these things you kind of know already intuitively. So that's what we discussed them. All right, so good. So now those are square root functions. What type of functions are the next one? Do y'all know what that is? Absolute value. Okay, so what's the thing about an absolute value? Well, what does an absolute value do?
It's like a negative positive.
That's one way you can put it. It makes a negative number positive number. So another definition too, in which I don't think I wrote it here, but absolute value. Another way it's put is it is the distance from a number on the number line to 0. Okay, why does that make sense? Because if I said -5, -4, -3, -2, -1, 0, what's the absolute value of -5? Is this 5. Okay, what's the absolute value of 5? 5. Okay, and sometimes I get classes like that because sometimes I think it's the opposite, but it's always positive. It's the distance from the number to 0. The distance from 5 to 0 is 5. The distance from -5 to 0 is 5. But in other words, it just makes any number positive. If it's already positive, it stays positive. Okay? All right, so then now back to this. Okay, back to graphing that. Here, and usually I use the whole board, FYI. I'm just working here because I'm trying to record myself. All right, so if I graph the absolute value of x, what's my strategy? The same strategy we used before, is just plug in some points. And then for absolute value, this wouldn't be a bad idea. My go-to points. Okay, that's not a bad idea to use those. What's the absolute value of -2? 2. Absolute value of -1? 1. Okay. 1, and then 2. And then you'll notice kind of like the parabola, it repeats itself where there's like a mirror image. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. What kind of shape does it form? Yeah, like a V. So this one is a sharp curve with straight line, or sharp turn with straight line, 2 straight lines there. So that's an absolute value. And then the other one is the absolute value of x minus 4, which here I think you'll do this one, but let me kind of guide you on that. Took a little too long on this, but on this one, it would be a good idea to start it with like a 0 in the middle, but how do I make this 0? What number in for x would make this 0? 4. So 4 would be my middle number. Then I want 2 numbers before that. What numbers are that? 3, and then 2 numbers after that, 5 and 6. Okay, plug in these points, this will give you a good picture. Okay, plug in those points, and then it should give you a good picture. Because I think if you tried plugging in -2, -1, you may not even seen the V part. You'll just see like a line. Okay, but if you plug these points, you'll see what I'm talking about. You're going to be able to see the V on that. If not, you can keep going, but I'll just kind of put it up here. So I told you to plug these points in. That would be what? Absolute value of 2 minus 4?
-2 equals 2.
Yeah, absolute value of -2 is 2. And then absolute value of 3 minus 4? Absolute value of -1 is 1. And 4 minus 4? 0. Absolute value of 0, 0. And then 5 minus 4 is absolute value of 1. Absolute value of 1? 1. Okay, good. Good. Usually somebody in the class mixes it up, but y'all did good. Okay, so 2. So then, now when you graph this, you should be able to see kind of the complete picture. 3, 1, 4, 0, 5, 1, and then 6, 2. There it is. Okay, here, let me ask you some bonus questions. Anybody know the x-intercept on this? What is an x-intercept? That's our next topic.
4.
Okay, good. So, what is an x-intercept? It is 4.
Where y equals 0.
Where, yeah, true. Where y equals 0, or where the graph touches the x-axis, right? Yeah, but yes, where y equals 0. Y equals 0. Right here. But good. Well, here's another bonus question. Does anybody know the the y-intercept?
4.
Okay, yeah, because if, and nothing tells you, but if you kind of go on the same path, you'll see that it's 4. Okay, so that's the next thing. Okay, so what I just finished showing you is how to graph anything, just plugging in points. How do you graph anything? You just plug points in, and you put the dots where they belong on the graph, and you can graph it. Okay. It also helps to kind of have a general understanding of the shapes of these. If you have an absolute value, it looks like a V. If you have x squared, it's going to be some type of parabola involved in it. If it's just x plus mx plus b, then it's going to be some type of line. Okay. So it helps to have that kind of general understanding too of that. But let's go on to x-intercepts and y-intercepts that I have here. So y-intercept is when x equals 0, and an x-intercept is when the y-coordinate equals 0. Okay, illustrated by these 2 points. So we'll do the first 2 together, and then I'll have you do some. Okay, so the first thing for that example, it says find the x-intercept. Okay, how do you suppose we're going to find the x-intercept?
Plug in 0 for that y. For 3, 0.
You plug in 0 for y, and then you solve for x. So how do you do that? You just, and plug in is a bad word. I should say, although I use it all the time. Okay, so substitute. We're going to substitute 0 for y. Okay. Oh, here, let's actually write it so that you have this down. To find the x-intercept, substitute y equals 0 and solve for x. Okay, so there you go. Whenever you're trying to find the x-intercept, that's the process. Okay, so then substitute y equals 0 and solve for x. So we did that part, or the substitute part. So 2x plus 0 is just 2x. What do I have left to do?
Divide.
I need to solve for x, so divide both sides by 2. I'm going to get x equals 9. And that's my x-intercept. Although, a question could ask you as a coordinate, what's the coordinate of this intercept? What's the 9, 0. Okay, so the coordinate is 9, 0. And let me use this space here. Let me erase this here. Okay, so the coordinate is 9, 0. So if I wanted to, I can graph that 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And now let's go ahead and find, because that's the next task, is to find the y-intercept. So who can tell me a process to find the y-intercept?
Substitute x for 0 and solve for y.
Substitute x equals 0 and solve for y. Good. Okay, so there's your process of finding a y-intercept. So let's do that. So how would that look like? 2 times 0 plus 3y equals 18. And then 3y equals 18 would be your result, because 0 plus 3y. And then what will we do from there? Divide by 3, right? So y equals 6. So what would the coordinate be of the y-intercept though?
0, 6.
Okay, good. 0, 6. So then 0, 6, which this is also another method of graphing, to graph by the intercepts, especially with lines. 2, 3, 4, 5, 6. Okay, because if it's a line, like how do I know this is a line? There's a couple of formats of lines. That's called standard form. Okay, and then the other one we saw earlier was slope-intercept form. Okay, but I know that's a line, therefore if I have 2 points, I have a line. Okay, so there it is, that's how you can graph the lines. But I gave you two, so that answers both the examples, I just kind of did it in one. Because one of the examples says find the x-intercept, and the other example says find the y-intercept. And then the next two, A and B, ask you to do the same thing, but I think I'll let you work on it, okay? Yeah. Like I said, the more you do, the better. Not because I'm lazy, it's more because I really believe that. The more you actually do, the more you're gonna get out of the class. So to me, this is where the learning happens, okay? So this is where you gotta put your effort. Yes. Oh, yes. Hey, how are you? That, well, they got it fast. They got it faster. Yeah. How long were you out there? How long were you? That was a whole hour. And then, oh, maybe they were off. Yeah.
Yes, sir.
Yes.